My name is Richard Haxby. I'm Technical Director here at Trelleborg Nottingham, and I'm also Technical Director for the Healthcare and Medical Division at Engineered Coated Fabrics. I've been working in the medical polyurethane industry for the last 20 years, developing coated textiles for mattresses, for wheelchair seating, positioning devices and cushions. What I'd like to do today is spend some time giving you some information regarding the physical properties, the key features of our fabrics and how they help make the best medical devices for your products. Polyurethane coated textiles like Dartex from Trelleborg have been developed to have the key physical properties required for devices that are going to be working with vulnerable skin. We're going to be talking about microclimate, about breathability, about stretch, the infection control properties of the fabrics, and how we can pull all that together into a sustainable package for the future. We're going to start with microclimate, which is the management of heat, moisture and airflow. Let's start by looking at the impact of heat. A 1 degree centigrade increase in temperature can lead to a 13% increase in metabolic demand. This is particularly challenging when the skin already has reduced perfusion due to the pressure from the support surface. Increasing the temperature from 30 to 35 degrees C can cause a reduction of 25% in the strength of the stratum corneum. Studies also show that if a constant pressure of 100 millimeters of mercury is applied, at 25 degrees C, a low temperature, no damage occurs. But at a higher temperature of 40 degrees, deep tissue injuries can occur. Now we'll look at the impact of moisture. Excessive water can weaken the crosslinks of the collagen in the dermis and also soften the stratum corneum. The stratum corneum is 25% weaker at 100% relative humidity than it is at 50% relative humidity. Moisture also increases the skin's coefficient of friction, and we all know that feeling when we've been in the bath too long and our skin becomes all wrinkly and sticky. So we can see why microclimate management is so important. The key property of a polyurethane coated fabric that gives us this microclimate management is its breathability, its ability for moisture to pass from next to the patient through the fabric. It does this through moisture vapor permeability. The key thing to understand here is this does not mean holes. There are no holes in the fabric, but water molecules will diffuse from a high concentration next to the patient to a low concentration inside the device. This can be demonstrated in a really simple experiment. We take a glass jar and we add some hot water as a source of moisture vapor. We seal the jar with a piece of coated fabric and place another jar on top. We can clearly see how the water vapor passes through the coated fabric and condenses on the jar above, showing how the water has moved from the area of high humidity into the area of low humidity. So why is stretch important? Well, the stretch properties of the fabric play an absolutely vital role in the prevention of avoidable pressure ulcers. The stretch properties of the fabric allow the surface to perform two vital functions. Firstly, immersion, which is sinking into the cushion or the mattress, and envelopment, which is the surface conforming to the shape of the patient to redistribute the pressure. The stretch properties of the fabric come from the knitting structure, and we have fabrics with two-way and four-way stretch. Two-way stretch fabrics stretch more in the width and the length, and the four-way stretch fabrics have an even stretch in the length and the width. In the laboratory, we can determine the stretch properties of our fabrics by looking at the force required to stretch a fabric by a certain amount of extension. Our research has shown that fabrics with a low modulus can be easily stretched with a low force, give the best performance. To find out more about our work in the area, you can visit the healthcare and medical pages of our website on the trelleborgecf.com. A fundamental property of our healthcare fabrics is that they provide an infection control barrier. All our Dartex fabrics are machine washable, they're wipe clean, they can be cleaned with common hospital chemical cleaning agents, and they're antimicrobial. Underlying all this, we want to show that Trelleborg engineered coated fabrics is a sustainable choice, whether you want a polyurethane coated or an uncoated fabric. The need to eliminate PVC in medical settings has long been recognised. Flexible PVCs can contain an endocrine disrupting compound known as a phthalate. These are known to be damaging to health and the environment. Scandinavia and the USA are leading the way in banning these harmful chemicals in medical environments. At Trelleborg, we recognise the need to do as much as possible to protect our environment. Our goal is to be net zero by the end of 2035. We are investing in a new task force called Polymers for Tomorrow, supporting the sustainable production and use of bio-based materials, regenerated materials and new polymer formulas. Our 100% recycled yarns are sustainably sourced, then knitted, finished and coated in the UK. So in summary, when you're specifying a new medical device, there are 4 key questions you need to ask your supplier about the fabric. Does it breathe? Does it stretch? Is it antimicrobial? And is it sustainable? Or to keep it simple, is it Dartex by Trelleborg? If you'd like to learn more and see how our technology and expertise can benefit your company, please visit our website or email us.